It sounds elementary, but for most of you, it's going to be very hard because it gets harder from here. So let's say we have a 0. We'll put 2, 4, 6, 8, and 10. Alright, and then we'll go the opposite way for negatives. Negative 2, negative 4, negative 6, negative 8, and negative 10. Right? So the next question is negative 3 plus 1. So I'll put negative 4 plus 2. Alright, so we start at a negative 4, which is over here, and we add 2. So each line is 2, so 1, 2. So the answer is negative 2. The easiest way to figure this out is regardless if this is negative 4 plus 2 or positive 4 minus 2, all we're doing is when you have one positive and one negative, all we're doing is subtracting and take the sign of the larger. In this case, when we had subtracted negative 4 from plus 2, right, all we had to do was take because the negative 4 is larger, the answer was a negative 2. But for the second example, for this one, right, the answer is positive 2 because the larger number is positive 4. Alright, so I hope that makes sense for you. Now the next problem is we have a negative 4 minus 1. Alright, what we're doing here is these two minuses make it a plus, so we have negative 4 plus 1. And same philosophy, we start at negative 4, we add 1, so it becomes plus 3, right? Because when we subtract them from each other, take the sign of the larger. When we subtract them, it's going to be 3, but we look for the large number with the larger sign. The largest sign is 4, and it has a negative, so the answer is negative 3. All right, now number 7 you will figure out. Number 8. So for number 8, when you have, let's say, negative 4 minus 2 or positive 4 plus 2, we know this is going to be plus 6, right? And the theory behind it is when you have numbers with like signs, right, the answer is going to be the same thing, a plus 6. Same philosophy. We're going to add these two numbers, negative 4 minus 2, right? That's 6, and because they're both negatives, the answer is going to be negative. Now, number 9 may throw you off a little bit because we have absolute values, alright? So when we have an absolute value of, let's say, negative 4, when we take off the bars, the absolute value, right, the answer is always going to be positive. So the answer is going to be positive 4. For number 6, it may get a little bit tricky because what we're going to do is we're going to have negative 3. Well, for instance, we have negative 3, let's say, plus the absolute value of negative 8. We have to write this equation two different ways. We have to write the equation such as negative 3. Well, it'll be negative 3 plus 8. There we go. Because when we take out the absolute value, right, we get a positive. So the answer is negative 3 plus 8. So negative 3 plus 8, because we have one positive, one negative, we subtract them. And the larger sign is 8, and so it's going to be plus 5 or positive 5. So you can just leave it like that. Number 7 you can do. 8 you can do. I guess when it comes to multiplication, what you need to remember is negative times a positive is a negative. Negative times a negative equals a positive. And a positive times a positive is a positive. So if we have, let's say for number 8, if we have 3 times 5, it's going to be 15. But if you have negative 3 times 5, regardless of where the negative is, it's going to be negative 15. And if you have negative 3, such as in number 10, negative 3 times negative 5, because they're both negatives, the answer is going to be a positive 15. And the same rules apply to division. So for instance, for number For number 16, you have, let's say you have 2 over 6. Alright, now when it comes to division, let's say you have negative 12, let's say you have negative 2 over 6, divide by 1/8. Problem is, you cannot do any division when it comes to fractions, so you have to change it to a multiplication problem. So it's going to become 2 over 6, and we're going to switch the numerator with the denominator with one of the fractions. It doesn't matter, I'm choosing the second one, times 8 over 1. Now we see if we can reduce. Let's see here, what's the common factor with 8 and 6? I'm thinking 2. 2 goes into 8 4 times, and 2 goes into 6 3 times. So then we're left with 8 over 3. Same philosophy applies. If this is a negative, then this becomes a negative. If they're both negatives, it's going to be positive. Alright, so that should help you with all that. Number 20. So number 20 is, let's say we have 6x squared plus 9 plus, and then parentheses, 3x squared minus 8x plus 3. First thing is we had to remove the parentheses. Because this sign is a plus, nothing changes. Alright, so all we had to do is rewrite the problem without the parentheses. So then we get 6x squared plus 9 plus, nothing changes, 3x squared minus 8x plus 3. This is an example of number 20. Now all we have to do is add like terms. Alright, this is a like term, this is a like term. So 6x squared plus 3x squared is 9x squared. Alright. We have a regular number and another regular number here. So 9 plus 3 is plus 12. And then we have only 1 minus 8x, so we'll just put 1 minus 8x here. However, if there was a negative instead, okay, so let me erase that. However, if this was a negative, then a lot of things change, and I'll explain. So let's say this is a negative. Because this is a negative, everything changes. Everything changes to the opposite sign. Alright, let me explain. So that positive 3x right there now becomes a, I'll write it in red, becomes a negative 3x squared. That negative 8x becomes a positive 8x. And that positive 3 becomes a minus 3. Then the same philosophy applies. Add like terms, 6x minus 3x squared is 3x squared. Plus 9 minus 3 is plus 6. And this stays as plus 8x. Alright, so that's the answer for, that's an example for our answers 20 and 21. Now for 22. For number 22, we have 3a cubed b times 7ab to the 5th. We just multiply the terms. 3 times 7 is 20. Alright, so next problem. So the next problem is the same philosophy, right? Except you got these parentheses. Okay. Well, actually, it's not the same philosophy. Alright, let me show you. So for instance, we got 6x, let's say to the 4th, plus y. And let's say I cube this instead. Because you got the parentheses, you have to multiply. You have to. Well, so you watch. So because this is 3, right? 6 cubed, right? So here, basically what we're doing is this. We're doing 6 cubed times x 4. Times times 3, see, not plus, times 3, and y times this. That's basically what we're doing. Anyway, 6 times 6 is 36, 36. Oh boy, 36 times 6 is like 216, right? So that's 216. 4 times 3 is 12, and this is y cubed. Alright, that's how you would do that. Alright, great, hallelujah. Next problem is we have FOIL method. Let's say we have x plus 5 times x minus 6. That's TT in the back making a lot of noise. And we have to use the FOIL method. First, outer, inner, last. Alright, let's do first. X times x is x squared. Then we have outer, which is x times negative 6, which is negative 6x. Then we have inner, which is this and this, which is plus 5x. Then last, which is 5 times negative 6, which is negative 30. All you have to do is simplify now, which is this becomes x squared, negative 6x plus 5x is just negative x, or negative 1x, and then this becomes minus 30. Alright, same philosophy applies to 25. 26 is division. Alright, next is, let's say, well, I'll go over one example of number 26. Let's say this is x to the 4th, and b squared and c, over, let's say, x to the 5th, b and c. Alright, what happens is we just subtract. 4 from 5 is 1, so that's just x. And then b from b squared is just b. And then c from c is nothing, alright? So that's the answer for that. Factoring. So let's say for number 27. You have, let's say you have 20a6b minus 5a4th b. Alright? So we have to find out what's the largest like term we can take out from everything. The largest like term we can take out is maybe 5, and we can take out a4, and we can take out b. And I'll explain. Because 5 from 20 is 4, a4 from a6 is a squared, b from b is nothing anymore. 5 from 5 is just 1, we don't have to write that down, and a from a is nothing, and b from b is nothing. Oh, okay, well, you could just put minus 0. Well, you can just put minus 1 here. I didn't even realize that. Okay. For numbers 28. For number 28, let's say you have, let's say we have y squared plus plus 14 plus 49. I had to do this in my head, I'm sorry. So what we have to think is, what factors of 49 when added or subtracted give you 14? Alright, so what factors will give you that? Well, factors of 7 and 7 equals 49, and 7 plus 7 equals 14. Alright, there we go. So we break the y squared into half. This becomes plus 7. And this becomes y plus 7 again. Alright, so that's the answer. The purpose of this is just to review. You should already know how to do all this. If you don't know how to do all this, look online, figure out a way to learn how to do this. Alright, let's see here. Next one is, let's say, is x cubed minus 125. Alright. Same, x minus 25. So the cube root of x without is x, and the cube root of 125 is 5. Alright, so we write the first one like that. Now we have to make a polynomial out of this, and this is simple. All we have to do is square x. So when we square x, for the first number is going to be x squared. And then we have to multiply these two terms, which is 5x, and take the opposite of that, which would be plus 5x. Alright, so the opposite. Then what we do for the last term is we just square it. So negative 5 times negative 5 is positive 25. Alright? So that's how you go about doing it. Since there's no positive, you don't have to worry about it. So what we did is we wrote down x minus 5. Alright? The first term we squared, which was x squared. The second term is we write the opposite of this, and we multiply x and 5 together. That's negative 5x, but because we write the opposite, which becomes 5x. Sorry, this should be x. 5x. Then we square the last term, and that becomes positive 25. Alright? That's how you go about doing it. Alright, for number 32, all you're doing is taking out the like term, right? So just simplifying. That's easy. So number 33 is, let's say you have 6x plus 2 equals 46 or something. So we have to subtract 2 from both sides because we're trying to get x by itself. 6x equals 44. We divide both sides by 6. Alright, and we divide both sides by 6. Those 6's crossed out. So we're basically doing how many times does 6 go into 44? I have no idea. But the answer after you reduce it, right, is that will be the answer, but you need to reduce it. Okay? Alright, next problem is, so let's say you have 2y plus 5 parentheses y minus, I don't know, 6 equals negative 10. Alright, that's a similar problem to number 34. All you had to do was parentheses. So 5 times y is plus 5y. 5 times negative 6 is negative 30. Right? And then equals negative 10. So let's simplify these two. That becomes 7y. Add 30 to both sides. So that's 10 plus, well, we have negative 10, then plus 30. Right? So then we're left with 7y equals positive 20. So y equals 20 over 7. Alright? Alright, so before you is an example of number 35. So this is absolute value, so you have to write the problem twice differently. So you're going to write this 3x plus 9, and then anything outside the absolute value changes. So, and this remains the same. So we'll have this, we'll keep this as equals 27, and we'll keep this as 3x plus 9 equals negative 27. Alright, so now we have these two different types of problems because of the absolute value. We have one with normal 20, right, positive 27, and one with negative 27. Now we have to work out the problem. So 3x equals 27 minus 9. Next one equals 3x equals negative 27 minus 9. And then you have to solve the problem, which you can do by yourselves. The next ones with the absolute is with less than and greater than. Same philosophy applies when solving the problem. So we won't go over any of that. Next is numbers 39 to 40, where we have to find the y-intercept and and graph. Alright, so for 39 to 40, when it says find the y-intercept of whatever's in the book, this is really easy. It's not as hard as you think. So all you have to do is the y-intercept, right? Well, the y-intercept equals, for this case, is, let's say if we multiply this by 0, right? It's just going to be 0 and this number. That's all it is. Since this is a negative 5, y-intercept is going to be 0, negative 5. If there was a 6, it would be 6. Keep in mind, what this is this is the slope. The slope here is 4 over 5. So when when we draw it, all right, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. The y, and this is x, and this is y. Keep that in mind. This is x, and this is y. The y-intercept is, this is x, which is at 0, and the y is at 5, negative 5, which is here. Then we go up 4 and across 5. So we go up 4 and across. So 1, 2, 3, 4, then cross 5. 1, 2, 3, 4, 5. Same again. 1, 2, 3, 4, 5. And then well, up 4, excuse me, up 4, should have been up 4 and then across 5. 1, 2, 3, 4, 5. Anyway, up 4 and across 5. So this is up 4 and across 5. Alright, the numerator's up and the denominator's across. And then we just draw the line like this. Alright, that's how you find the y-intercept. Right, and then I explain you what the slope of the line is. So, for number 41 to 42 is a little different. So the formula for 41 to 42 to find the slope of a line is m, that means the slope, m equals y2 minus y1 over x2. This should be y2 minus y1. This should be x2 minus x1. So let's see here. Let's have the formula I gave you was 1, 5, and negative 3, 2. Alright, this is x1, y1. This is x2, y2. Alright, all you have to do is just plug that in the formula. y2 here is 2 minus 1 over x2, which is negative 3 minus 1. And you can figure that out, and you can be able to find out the slope. Next is numbers 43 to 44, which asks us to find the slope of a line. Alright, so let me change the problem up a little bit. Let's say it's 5x minus 2y equals 8. Well, to find x, we got to get y by itself, so we'll have negative 2y minus 5x. Excuse me. We'll have negative 2y equals, subtract 5x from both sides, plus 8. Alright, yeah. Now we have to divide both sides by negative 2. Divide this by negative 2. Divide this by negative 2. This crosses out. So we have y equals negative 5 over negative 2x plus 2 can go into 8 4 times. Right, and then technically, this should, since they're both negatives, this goes away. Alright, so there we go. We have it in the correct formula. And the slope is simply going to be m equals 5 over 2, right? Because this is the slope. So that's how you find the answer for that. Then for number 45 to 47, well, that's easy. You already know how to find the y-intercept, right? So now all you have to do is graph, for instance, for this problem, right? Let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? X is positive 4, which starts here. Okay, that's the y-intercept. Then we go up 5 across 2. 1, 2, well, here I'll go opposite for this one. 1, 2, 3, 4, 5. And across 2, so 1, 2. And again, 1, 2, 3, 4, 5, and 2. Alright. That's how you would do 39 to 47. So the example before you is example of 48 to 51, alright? Which, what you have to do is put this into y equals mx plus b form to solve this particular problem. So y equals m. Our m is 3 over 4 x plus b, right, which is 7, alright? That's all you have to do. This is how you would solve 48 to 51. Now for 52 to 55, it's different. You need to do another formula because you have 2 points. such as -5 and let's say 4 and 3 and 7. To solve this, you need to use the following formula. Y minus y1 equals m times x minus x1. Okay? So this is x and this is y. This is x1 and this is y1. Actually, forget that. Sorry, you would use this formula for something else. Let me write the proper formula. The formula is a little different. We need to find the slope, but anyway, this is x, and this is y, and this is x1, and this is y1, like earlier. Now, first we have to find the slope. So the slope is y2 minus y1 over x2 minus x1. So our y2 here, this is x1. Now our y2 would be 7, and our y1 would be 4 over our x2, which would be 3 here, our x1, which would be -5. So minus minus becomes a positive 5. So this changes into 3 over 8. Alright, that's our slope. Now the formula, which is the correct form I had written earlier, which is y minus y1 equals m times x minus x1. Alright, so y minus our y1. We're just going to worry about our y1 and x1. Our y1, which is 7, equals our slope, which is 3 over 8x, minus our x1, which is 3. Okay. Then to get it into the proper form, or to get y by itself, or we need to add 7 to both sides. So y equals 3 over 8x plus 7 on both sides, which comes out to be positive 4. Alright, that's your answer. And then you can graph if needed to graph. Alright, and that's the same philosophy applied to problems 54, 55, and 56, and 57. Next is the quadratic equations. So when it says quadratic equations, it's not that hard. All we're doing is factoring to get the answer. So I gave you the page number in your book to look it up if you need to look it up, which is page 136. So let's factor this into two binomials. So we have to figure out what two factors of 12 when added or subtracted. What two factors of 12 when added or subtracted will give you 2. Well, excuse me. Let's see here. 2 times 6 is 4. 2 times 6 is 3 times 4 is. You know what? Let me just change this to 4. All right. Alright, I changed it to 4, make it easier for ourselves. Alright, so we said 2 and 6. Alright, 2 times 6 is 12, and 2 minus 6 is 4. That makes it a lot easier for us that way. So we have x and x. The larger number will go with the will be positive. So this will be x plus 6, and this will be x minus 4. X minus 2. I'm sorry. And when you use the for method, you'll see the exact answer. Because what we're looking for is what two factors will give us, or what order will give us -4. Or negative 2 plus 6 will give us negative 4. 2 times 6 is 12. So that's the theory behind it. So now I want to ask you to give me what x equals, to be exact. Alright? X is going to equal the opposite of whatever's in here. So this will be x equals negative 6, the opposite, and this will be x equals the opposite, which is positive 2. Now, let's say you have one of these. Let's say you have x plus 3 over 4, for instance. Alright, or you get x equals plus 3 over, well, no, I'm sorry. Let's say you have 3x plus 4, alright, in one of the binomials. So what you're going to do is x equals the opposite plus is negative. This 4 becomes the numerator, and this 3 becomes the denominator, right? If it was, let's say, 5x minus 2 is one binomial, x stays here and equals, this negative becomes a positive, and this 5 becomes the denominator. Okay? So that's how you would solve 57 to 60. The next set of problems are not hard, as they're not hard. It's completing the square. So the first problem is x squared equals 16. So I'll use a different example. Let me use x squared equals, let's say, 81. So you have to square 81. So let's say you have to square everything. You square this x squared, and you square the 81. When you square x squared, it becomes an x, and when you square 81, it becomes plus minus 9. Okay? Now, that's how you would solve 61. Let's say you have a problem such as 62. So for problem 62, let's say you have x plus 4. X plus 4 squared equals, let's say, 6. So same philosophy, you're going to square this, and you're going to square this. After you square it, you're going to get the absolute value of x plus 4 equals the square root of 6. Then when we remove the absolute value, just like how we're adding absolute value bars, everything outside the absolute value bar changes. This can be plus, this could be minus. So we'll write plus minus the square root of 6. If you can take out the 6 from it, for instance, if this was 25, then it would be plus minus 5. Right? But since we can't take out anything, it stays at 6 inside. So that's pretty simple to understand. Now, if we were to want x by itself, which is what I prefer, so you have x equals, you have to subtract 4 from both sides, x equals minus 4 plus minus the square root of 6. And that's how you would solve number 62. 63 is a little bit complicated. So I'm actually going to do 63 for you, and then 64 to 65 you can do on your own. So the reason why 65 is a little different, there's some steps that are involved, and we went over it, but I'm not sure if I went over it very well. So we have x squared plus 8x minus 9, right, equals 0. So pay attention. So we want to get everything equal to 9. We want all the x's on one side. So we'll have x squared plus 8x equals, we're going to add 9 to both sides, all right, equals positive 9. Now, what we're going to do is make a binomial after these x squared. So we're going to have x squared plus 8x plus a number equals 9 plus a number. What is this number? Well, what we're doing is we're taking this 8x and we are going to multiply it by 2. Alright, times 2, or 8 times 2. So 8 times 2 is 16. And this number we're going to put here as well, which is 16. Now we simplify. Now basically what we have is x squared plus 8x plus 16 equals 16 plus 9, which is 25. Right? Now the second step. So basically we can change this into two binomials, which is x plus 4, right, times x plus 4. You see what we did? That's why we multiplied this middle term by 2, so we can make it into two. These binomials should be the same, x plus 4 plus x plus 4. So x plus 4 plus x plus 4 is the same thing as saying x plus 4 parentheses squared, correct? Equals 25, correct? So then we'll square this and we'll square this, right? Same procedure. This becomes absolute value, right? And this becomes, well, we'll stick with this as with the square root of 25. When we take out the absolute value, we just have x plus 4 equals plus minus the square root of 25. Alright, then we have to move 4 to the next side, which becomes a negative 4, right, because we subtract 4 from both sides, plus minus, we'll say 5. Okay, and then you solve it, so we'll have x equals negative 4 plus 5, and x equals negative 4 minus 5. So x equals negative 4 plus 5 is 1, or negative 4 minus 5 is negative 9. Alright, that's how that is done. So for 67 to 66 to 67, I'll do that with you as well, because that's hard. So we have 3x squared minus 13x equals 10. So we already, like the other one, we already have the x's on one side and we have the 10 on one side. So that's good. But we need that middle number, right? Which is a little bit tricky here, but let's figure this out. We want x by itself. We don't want to have an x squared. So we're going to factor out the 3 from everything. So, or divide 3 from everything. So we'll take out that 3 and we're left with x squared. Take out the 3 from 13, which is basically we're dividing it from 3. You see that? Plus, that number equals 10 plus that number. So we have to multiply by 2, or squared like how we did the other one. So 13 squared is 169 well, the philosophy here is we're multiplying by 1/2, then squaring it to get a perfect trinomial. That's what we're trying to do. So since I didn't go over it, I'm just going to give you, which is 169 over 36. Okay, and then when you and this over here is going to be 169 plus 12. All right, I didn't really go over it, so I'm just giving you the answer here. So what happens now is, after you do a whole bunch of math, we're going to be left with x minus 13 over 6 squared, that's what we're trying to do, equals, after we combine this 10 and this together, we're going to get 289 over 36. Alright, just write down what I write down. Then what we're going to do is we're going to square this, and we're going to square this. Okay? After you square them, you're going to get x minus 13 over 6, and that plus minus 17 over 6. And then this is what you get so far. And then from here on, you should know what to do. Because x equals, hold on, x equal, I forgot to write the equal sign. So x minus 13 over 6 equals plus minus 17 over 6. That was a hard one. Go ahead, solve that. I'll make this extra credit. It's extremely difficult, and I don't think I went over that. Alright, 68 to 69 is easy. That's just solving by the quadratic equation. So the quadratic equation, which you all should know, is, I'm trying to choose, is minus b plus minus the square root of b squared minus 4ac. So x equals, the quadratic equation is minus b plus minus b squared minus 4ac over 2a. So I'll do the first problem with you. Alright, so we have 4x squared plus 3x minus 9 equals 0. So before you even start, you have to make sure that the problem equals 0. So in our homework, in the assignments, 47 to 49 is not set to 0. So you're going to have to fix that. 72 to 73, I'll explain a way to solve that. So let's just plug it in. So this is A, this is B, and this is C. I'm not going to solve it, I'm just going to, well, maybe I will. So we have x equals negative b, which is negative 3, plus minus square root of b squared, which is 3 times 3 here, which is 9, minus 4 times a, which is 4, times c, which is negative 9, over 2a, which is 2 times 4, which is 8. Alright, so then we're left with negative 3 plus minus the square root of, well, 4 times 4 is 8, 8 times 9 is negative 72, so you have 9 minus 72, which becomes a plus, because they're both going to be negative, and I'm skipping the steps in my head, but I'm sure you can follow along. Over 8. Alright, let's go back here and finish that. So we have negative 3 plus minus x 9 plus 72. And what's 9 plus 72? 9 plus 72 is 81. Equals 81 over 8. Okay. And then after, it looks like I may have done some math wrong here. 4 times 4, hold on. 4 times 4 is 8, right? 16. Oops, I made a mistake. So that should be this should be 144. I'm sorry. 144 plus 9. 144 plus 9 is 153. Okay, made a mistake. Okay, that makes sense. Okay, minus 3 plus minus. Then you can simplify that to. Alright, so when we factor out 153, you can take out a 9, I think. No, you can take out a 3, yeah. 3 out of it. So or 9. So that gives us, oh, excuse me. So that gives us a set of 3 you can take out of it. So that gives us this. Okay, over 8. So that's your answer. So the answer is x equals, and then negative 3 plus minus 3 times the square root of 17 over 8. Alright, so that's how you would do the quadratic formula. That was kind of rushed, but this should be only a review. So let me give an example of 72 and